What's up, my analysts, and welcome to the first practical applications of the Open Threat Hunting Framework video. I think this is going to be series, although I can't make any promises on how good I am about getting this content out, but I am going to try. This is the video that I really wanted to make, and it focuses on the two questions that I get asked most often, which is, how do you know what to hunt for? And then how do you build a process to operationalize threat hunting? And so we're going to cover that, which is all documented very well into the framework. But I thought, I'm a visual learner, and I think it'd be a lot easier to see someone walk through it step by step, and then they can go back through and read the framework. Trigger warning for intelligence analysts and red team operators out there. I'm going to show from a very basic level how you could use some open source intelligence to figure out what you should be hunting for. I totally understand that threat intelligence is a much deeper and broader subject, and there's way better ways to do that. If you have processes that you would like to see implemented into the hunt framework for how to identify what to hunt for, please submit them to the GitHub project. Red teamers, I'm a total noob. We're going to be doing things out of the box, and I get it. I'm just saying, don't at me. We're at the 101 level, okay? So we're going to step right into it, and I'm going to show you how we can go about building and running a threat hunt and try to find something that would be high impact and valuable to the organization. So it wouldn't be me if I didn't have slides, and it wouldn't be me if there wasn't a dog on those slides. So let's step into it. If you did not read the framework yet, or if you did not attend Black Hat, sorry for you, but you missed the show. One of the most important findings that actually spawned the Open Threat Hunting Framework project was this research study. And what we found is that the high performers within the hunters, the hunt community, they all had a well-defined mission and vision, and they designed their goals and objectives to ensure that they kept the program aligned with that. So I wanted to make sure that we mention this. So here, this is our make-believe hunt program at Dwyer Corp. And our mission here is to be the driving force in advanced and automated adversary detection. That little sentence actually means a lot, guys. And you're going to see how everything kind of maps back to that. It's going to have an impact on how I design the threat hunt, how I actually craft my hypothesis, how I focus in on specific things. Because at the end of the day, our mission is to create the best automated detections. And through that mission is going to help me define how I proceed the entire time. And you'll see, my boss at Dwyer Corp has given me this goal. And in the goals, you can see maps back to the vision, right? And the mission. So we can say within Q4 2021, in this pretend land that we're working with, we have a lot of data about 2021. So we're going to pretend we're in that time frame. And we say create 5 new threat hunts relevant to Dwyer Corp that meet the requirements for the SOC to be migrated to a new automated detection. This is a great goal because it gives me time bounds. It gives me specific metrics. I need to do 5 new threat hunts, which means they can't be something that we're already hunting for or have a detection for. They have to be relevant to Dwyer Corp. I'll touch on that in a second. And then it must meet the requirements for an automated detection. You can see that ties back to our mission. We want to design threat hunts that are going to be great for the SOC to build detections for. Hunters hunt, operations people manage detections. If you want to have that good relationship, the best thing you can do is to give them really good, tight threat hunts that are going to make for good detections. Relevancy. Now, this is asking the question, what should I be hunting for? This is covered in great detail. We're going to zoom through this, but I think like watching me go through it, it'll help the words click whenever you're reading through it. So relevancy is like, this is what you should be hunting for. The approach should be like, I should understand what threats are most applicable to my organization and which ones are most likely going to impact me. And that's the stuff that I should be hunting for first. And through that, I can create a nice prioritized list of things that I high impact to impact the level of risk to my organization. And that's how I'm going to go through this. So there's multiple different ways you can go about this. We're going to go through some open source ways to kind of just like connect the dots here. I can build this, even if you're just like an individual operating in an organization, or if you have a hunt program, maybe you don't have an internal threat intelligence team, but you do have a hunt program, you could kind of build a nice little process around this to figure out, hey, what's relevant to me, and then prioritize and assign and figure out what we're going to tackle first. Okay, so everyone kind of knows about MITRE. And MITRE is great. I'm not saying it is great, but I don't know, I think the Electronic Transactions Development Agency, their threat actor encyclopedia, which is fantastic resource. This is where actually I like to start, because Dwyer Corp, we are a small retailer in the United States. So what I can do here is I can just say, oh, well, show me all of the threat actors that have observed operations for United States retailers. And through this, I get like a nice list. So I've already carved down their entire encyclopedia into a subset that we know have done stuff. They have been attributed to attacks in the United States retailers. And each one of these, you can see they have a last observed date. We're in Q4 2021. So we can actually prioritize this list even further to say, well, I want to look at threat actors that are active now or in the very near time frame, rather than something from 2019 or 2015 even. And I can go through in each one of these. So we'll click on Fin7. Fin7, they're famous, and they have a lot of good information around them. So we can click in here and see their different names. I can use that to do some more pivoting, to look, do some searching for the other names to get more information about stuff that they've been doing other than different vendors. See, their motivation is financial crime, so that's relevant to us. We do have money at Dwyer Corp, albeit a little. We get by. So we have money to lose, and they could be motivated by that, so that's applicable. What I like about the way that this is formed is you can actually watch the evolution. They do it in chronological order for the operations that they have attributed to them. And we can see that Fin7 has kind of evolved year over year, from moving from doing like point of sale or ATM or credit card kind of theft into more recently, starting in 2020 into 2021 now, into ransomware. And we can say, oh, ransomware, definitely relevant to us. That's a threat that we're concerned about. It's a threat for everyone. And I can go back and I can repeat that process over and over and over again for all those different groups. And then I can pivot into MITRE and do the same thing and say, okay, now let's go ahead and search for retail. It's a little bit more cumbersome because you can't just filter by that. I mean, you can through the API, but if we're talking about just level 101, looking at this, you can say, okay, Fin7 again, retail, and I can get some more information about what they've been doing lately. And eventually they're going to tie back to, okay, Fin7 mostly attributed to doing ransomware. And through that process, going through that over and over again, I can build something like this. And this allows me to say, okay, based on who we are, here are our top list of groups or threat adversaries that we should be concerned about. And what are all of those adversary groups doing mostly or recently in terms of now, right? And we can see that the majority of them are focusing on the ransomware as a service, or executing ransomware for profit, which is not shocking given the time of Q4 2020-21. So that's our threat. So we can say, okay, so here's our adversaries that we should care about. Based on those adversaries, what kind of threat type should we be concerned about? Ransomware is the one. And then we can go through the next evolution of is like, okay, of all of these groups, of all of the ransomware threats out there and variants, and I understand that the variance of ransomware doesn't necessarily matter in terms of the adversary, because it's more of as a service model and people can use whatever they want. But you can use, indicators or recent ransomware attacks to identify who is more active at a time, so who you would want to bubble to the top. And in Q4 2021, you could see, the two top were Lockbit and Conti, but then Conti takes cake. There's just more attacks happening. You can see that there's more happening with Conti. So we're going to focus in on them. So we've taken all of the threats, done some open source intelligence, searching around just for attributed things that tie into US retailers, and then got to adversaries, got to the threats, and then who is most active now. So we're going to start there. So this is a good place to start. And I get, there's probably better ways to do this or more advanced ways to do it, but this is easy to do. Anyone can kind of do that. And through that, we can say, okay, tell me more about Conti, and we can get some validation. So all of the big security vendors out there put out fantastic content that we should be using as hunters to curate, to understand what is happening from a threat landscape point of view. So we have some screen caps here from CrowdStrike, IBM, and Palo Alto. And through that, we can say, okay, ransomware is definitely what we should be concerned about most based on our industry. Conti is very active. Retail in the United States is their third most popular target. And then from Palo Alto, we can say, well, how does Conti do ransomware? What kind of vulnerabilities are they using? We got a list over here. But like this table over here by Sophos, this stuff is out there. People are doing it. If you just follow the breadcrumbs, you can get into some really good understanding even without having a dedicated threat intelligence team. And I can see I'll tie this together. But now we're talking about, okay, so I got Conti ransomware. Now I understand how Conti does ransomware. Now let me start triaging how they actually do it and think about what's relevant to us and what we should prioritize on this list. We start there on initial access and we say, okay, they exploit FortiGate firewalls. I don't think we have FortiGate firewalls. Let me shoot a message to the NetOps. Guys like, well, we don't have FortiGate. Now, I'm not saying we're not going to do a hunt for that, but because there could be one lying around. That happens all the time. But maybe we don't push it to the top of the list. And then they do spear phishing. Well, every ransomware person does spear phishing, and we already have hunts for spear phishing. Let me see how Conti's spear phishing campaigns have looked like based on open source reports. Well, it seems like our hunts and our detections would probably already align with that, so we're not going to bubble that one up to the top. Maybe there's some tweaks we can make specific to their style, but we're not going to make that our number one. Okay, what's proxy shell? Well, proxy shell is a vulnerability in Exchange, on-prem Exchange. We have on-prem Exchange. Okay, so this is relevant. We don't have a hunt or detection for this already, so let's find out a little bit more about that. So we go ahead and we do some research and just searching around about proxy shell, and we find out that proxy shell is actually a exploit of 3 vulnerabilities in my Microsoft Exchange, which allows a remote adversary to bypass authentication, get privileged access to the Exchange commandlets, and then through that, the adversary can either use an arbitrary file write vulnerability to create a web shell, or they can just get access to mailboxes and pivot into things like OWA and use that access to try to pivot into internal resources. Of those 2 paths associated with ransomware, web shell seems to be the by and far the most popular of it. So we can focus in, we triage this even further and say, okay, so web shell on Exchange, and let me check if our Exchange servers are vulnerable to this. They are vulnerable to this. Okay, so now this is a really relevant high impact threat because this allows a remote adversary to basically white card themselves into internal infrastructure at a privileged level on Exchange, which is a juicy target, obviously. So we've chosen this. So we need to understand, okay, a little bit more of like, what is the proxy web shell? How does that manifest itself? You just do some searching on this. This is just 5 minutes of searching about proxy. You can get an understanding. We see that through the Exchange commandlets, adversaries generally use 2 commandlets. One is to export a mail message. The other one is to export or to create an Exchange certificate. In both cases, the code for the web shell is actually written into the mail message or certificate. Those things are exported to disk and to a location where it is remotely accessible. So somewhere within the IIS app pools that is accessible to the adversary where they just connect to it over HTTP, and then they have interactive access to the system. Between those 2, the new mailbox export request is most commonly used for web shells. And as I said before, adversary basically crafts a email draft message, and in that mail message is the code for the web shell. Then they run that export request commandlet to say, oh, export that content to a file called, yeet.aspx and export that into one of the Exchange directories or to www root, something that can be loaded by IIS and make it accessible. So we have some behavioral keys there, right? So we see that, in each one of those cases, but we're going to be writing a file to disk, and that's something really good to key in. It's hard to change, right? Because it needs to export something, and that export commandlet, hard to manipulate to say inject it into memory or something on that. It has to write to disk. So that's a good indicator that we can start building off of. The other thing is that we know, that's just generally from web shells, if you do some searching, or even if you search proxy shell, web shell, how it actually works. So we know that's going to be loaded by the IIS worker process, that W3WP. And so from there, we can say, okay, there's probably going to be some processes spawned as a child to W3WP. We can key in on that, which would be a generalized kind of behavior as evidence that this has been exploited on Exchange. Looking out to see if there's any implementations of this, we can see there's plenty. There's a ton of stuff on GitHub. Metasploit has it as a module. We're going to focus in on the Metasploit piece because it's easy to use, repackageable, and it's been observed in the wild. And we know just by doing more searching that the ransomware operators are going to try to generally towards the easy to use solution. So okay, we have an idea. So now we can start designing our hunt. This is the open thread hunting framework process. There's a lot of thread hunting processes out there. You don't have to use this one. If there's a better one, submit it to the GitHub repo. But we're going to walk through this. I'm going to show you. This is like how you would operationalize a thread hunt. Okay, so we start with the goal, right? So here is our goal, and it's important to define a goal because we need to know whether or not we're successful or not. And so I'm not going to read through this, but you can say one of the things I want to show you is like, okay, so we're really hyper focused on the Metasploit proxy shell remote code execution module. Because again, at the end of the day, we want to migrate this to an automated detection. And to do that, we have to have some type parameters. And we're going to say, well, we're going to key in on the file activity on the Exchange server, because if we can catch, something writing a file, then that's a really good indicator, right? Because it should be like, hey, how often or should an Exchange server be writing a script file to one of those directories? Probably not all that often. So that's our goal. And here's our hypothesis. In the framework, I don't want to read through this just for the sake of time, because if you let me talk, I will talk. We show some strategies that you can use to help form a hypothesis, even if you're not really well versed in crafting them. And we use the given, when, then template. So that allows you to create a testable statement. So we're saying, given the situation, so if at the very core, this situation has to be present and relevant. So given you have an Exchange server that's vulnerable to those vulnerabilities, when this is exploited, then you will see an ASPX file written to one of these two directories based on how we understand the Metasploit proxy shell RCE module works. You can just search it. That's up on the internet. You can see exactly how it works. So we have a good understanding of how it actually works, so we can use that to build our hypothesis. The next step is to validate the data. So there are hypotheses like, okay, this is where before I go down the rabbit hole of executing this, I should make sure that data is available. So if we pivot into our Exchange server here, again, we're working off of Sysmon because we're trying to do things free and easy. And we're going to filter this by event ID 11, which is file write. We don't have it. So that's an important thing, right? That's why we have to validate our data, because we can't do this thread hunt without data. That's a finding in and of itself. But that doesn't mean it has to end there. So we can go back and say, well, we still had that process activity. Maybe we can do that because we do have process creation event data on our Exchange. So we pivot and we create a new goal and we say, okay, well, we couldn't do that. We'll cycle back through and say, okay, we'll develop a new goal and a new hypothesis based around the behaviors that we understand of the process activity when this exploit is successful. So we're going to be looking for W3, WP, spawning, command interpreters with suspicious command line. That's what we're saying. Like, given whenever this happens, we should see this behavioral on the other end. And we won't know that unless we test it. So we're going to create some test data. Operators, don't cringe whenever I type through this. All right. So this is just a Kali box that's sitting. Let me zoom in a bit. Hopefully you guys can see that on the same network as Exchange. And we're actually going to run this. We're going to run exactly what we're looking for. And this is important, right? Because we do want to create as realistic data as possible. So we can just search for a proxy shell. We should get a module. There's guides on how to do this, so you don't necessarily have to follow me. Use that module. And we can do show options. And we can see that the only exploit target available to this module is PowerShell. So we can actually go back and say, oh, we can adjust our hypothesis to say not command interpreters, but actually PowerShell will be launching as a child of W3WP as system. Maybe we key in on that. You don't have to, but it would be nice to keep it really tight. So all we have to do for this is to set our where we want it to connect back to. That's just that Kali box, and then we have to put in the IP of our Exchange server, which should be vulnerable. And then when I hit enter, it's going to connect into it. It'll use AutoDiscover to find a mailbox to create that mail message, export it into a randomly named file in one of those directories, and then we should be able to interact with it. So we'll do an exploit, and it's going to run. And we can see, yep, here's our saved mailbox and email address. And then it's going to go ahead and export it. And we can see right here, this is where our web shell file has been exported. And then what it's going to do is spawn a interpreter session on Exchange. So if we go over to Exchange and we pop open their task list here, we can see that, oh, there is a PowerShell process running a system. And this is likely what we're going to be looking for. So what is that process ID? 20892. So let's go ahead and look in Sysmon here. Say, okay, that's definitely sus, but we have command with power. So, and potentially we might be able to work off of this current directory where command is working out of inetserv with a power parent of PowerShell. Maybe that would be a different strategy we can take depending on as we cycle through this. But let's go ahead and run this back until we get to where our true hypothesis was trying to find that IIS work in progress. So that's not it. Okay, so here we have, here's our process that we had. What is the parent of this? Oh, no, it's PowerShell again, but it's a new PID. So let's go ahead and pivot off of this. All right, that's con host. And here's our process. And what is the parent? Okay, bada bing, bada boom. So this is good. So here's our IIS worker process. And we can see that it's spawning a PowerShell with a bunch of gobbledygook. Now, this will depend on how you want to develop your strategy. As the process defines, is like this is an iterative thing where you're going to have to test some different things that work and maybe don't work. If you want to stay away from updates to this module that may change, the obfuscation may change if you try to do off keywords like from base64 string or invoke expression, or even this registry key, which has worked really well in the past, but this obfuscation may change. Perhaps we can just say, okay, well, we know that proxy shell is going to be working off of the MS Exchange OWA app pool, and it's going to launch PowerShell with a bunch of stuff. Maybe what I do is just say, okay, I'm going to go back and say, so it's running a system. So why don't I, instead of trying to do off keywords, why don't I create a strategy with saying, like, okay, let's look for PowerShell processes running a system. The command line is large, and the parent is W3WP with the OWA app pool in the command line parameter. So that's going to be our strategy. And then the next thing we have to do is validate that this actually works. And this is pretty easy, right? So what we're going to do, and this is the iterative process, maybe I find out that 200 characters is just not long enough. I get a lot of false positives and I need to go back through, bump it up to 500,000 or whatever the character thing needs to be. Or maybe I need to switch to doing keywords like from base64 string and that registry key and invoke expression in there. And I just need to work through that until I get to the point where I can go back through all the data that I have and say, the only thing I found is my test data or real evil. And so if I get any hits, I either need to tune my strategy or to address the false positives or change my strategy, or get to the point where I find some real evil and then kick that over to IR, or the only thing I find is my test data. But I did validate because we did the real thing, so we know this strategy works, and we didn't find any else for a false positive. So then the last step there is once we get through that, we're going to document our findings. And like I said, we had more findings than just whether or not we found evil. The first finding that we had is that, you know, the servers were vulnerable and that needs to get fixed. So maybe that's ticket off to vulnerability management or ops, say, hey, we got to patch this, or maybe it's me itself that has to patch it, but we need to document that we actually found this because that goes into metrics. This is all observational stuff that feeds the value of threat hunting. The other thing that we found, file activity is not being monitored on Exchange servers. And then, you know, there's more than one vulnerability out there for Exchange that allows to write a web shell. And perhaps we should enable monitoring for at least those specific directories. And that's a finding as well. value added. We're improving our capabilities. And finally, that the finding was we did our hunt. The hunt was successful. All we found was our test data validated that it worked. We're going to submit this hunt to the SOC for migration to a detection. So that's great. And now we have a date, and we can close that out whenever it gets migrated so that someone doesn't run this hunt again. As far as automation, specifically, like I've said before and as documented in the framework, is we want hunters to hunt, we want operations people to manage detections. I understand that that's not the case for every organization, but we should try to get to that place. For automations, I highly recommend the Palantir Alerting and Detection Strategy Framework. I believe all SOCs should have adopted this as the way that detections are documented and implemented into the organization. It's one of the best pieces of work in cybersecurity for the last few years, in my opinion. So make sure that you implement this as a requirements phase to say, hey, before any of my hunts get automated, I want them documented in something. And this is a great example of what to use. So I understand that that was fast, but it was fast on purpose. I didn't want to keep you here for 45 minutes. But if you like, I guess I should say like and subscribe. That's the thing that you're supposed to say. But I hope you enjoyed it. I hope it made sense. Follow me on the socials, Tactical Sec on Twitter or John Dwyer X-Force on LinkedIn. And yeah, if you have any questions or concerns or comments, or if you want to add to the project, find it on GitHub. And I'd love to hear your perspective or your great idea.